The purpose of ships are made to float across water, on mass transportation. You may be curious how these metal cruisers and passenger ships can float on water and how they can possibly sink. First, you may think of tsunamis, leaking ships, or other catastrophes you might have seen in movies. However, there are very scientific reasons why ships are able to stay afloat or sink to the bottom of the ocean. There are two major factors to it. I'll give you a brief explanation about buoyancy. Buoyancy, the tendency of an object to rise or float when immersed in a fluid, either liquid or gas. Any fluid exerts an upward force of an object immersed in it. The strength of the force is determined by the weight of the fluid displaced by the object. If the weight of the water displaced is less than the weight of the object will sink, which means that the ships have to measure the water displacement accordingly for them to not sink. Let's say we put a mini boat on a tub. The boat displays 30 grams of water. Now that 30 grams of water that was originally there will try to push upwards towards the boat. We call this the Archimedes principle. The next factor is density. Density is mass per unit volume. In other words, it is how packed molecules are in a unit volume. From keeping the ship from sinking, the ships have to be designed that when it enters the water, the mass per unit volume of the ship has to be less than the mass per unit volume of the water. We got four different types of balls to represent each different types of ships. The beach ball will float on the top of the water because the air inside the beach ball is less dense than the water. Basketball will still float, however, it will displace more water due to more compact and dense air compared to beach ball. Bowling ball will sink to the bottom because its density is much greater than the water. The golf ball would also sink to the bottom. Even though its size is small, it has more density than water, therefore sinking. I hope you have a good idea now. Ships will need massive support from both buoyancy and density to stay afloat. Ships have to be designed carefully to meet these criteria, such as density having to be smaller than the water. Thank you.